Okay, section 4.2, triangle congruence by side, 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 and side angle side. This is the beginning of the barrage of proofs that we're going to do. So take careful notes, make sure you ask questions. This could get a little difficult, so you need to make sure that you're following along with this. All right, first postulate, and this is the one, this is why I said side, 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 because what this says is if you have two triangles and three sides of one triangle are congruent to three sides of another triangle matched up somehow, however they will, then the two triangles are congruent. So you'll literally be able to look at the triangles, see that they have three sides in common, and you'll be able to prove them by side, side, side postulate. Okay, so let's try one of these so you can see it in action. All right, just like before, first step is the given. We're just going to copy this down like we did before. We're going to put given. And then we're going to mark our picture with what we have so we can see it, because sometimes it's easier if you see it rather than just write it down and just hope for the best. Okay, so we're going to actually mark our picture. So it says AB is congruent to CB, and it says AD is congruent to CD. So that's what we have right now. Right now our triangles have two sides in common. We need a third side. The third side happens to be this line that runs to the middle. So if you remember from the last section of notes, this third side is congruent because they're shared. And when you write it down, it's the reflexive property. And we can use this as much as we need to. Anytime they share a side like that, then they're good. So now my triangles have three sides in common with each other, so we can prove our triangles. So we say triangle ABD congruent to triangle CBD by side, side, side postulate. Okay, that's how these work. You have to get a certain number of things, it's like a shopping list, and then once you have everything on the list, then you can prove them congruent. Alright, let's try another one. You can already see this one's got a little bit different information in it. So we're going to copy the givens. H is the midpoint. There's how you abbreviate midpoint if you need it, of GK. And then we've got HF is congruent to HJ, and FG is congruent to JK. Given. Alright, let's go mark this on the picture. H is the midpoint of GK. We can't mark on the picture yet. But we can mark that HF is congruent to HJ, and we can mark that FG is congruent to JK. So right now our triangles have two sides in common. So if H is the midpoint of GK, that means it's in the middle of GK. That means it cuts that segment in half, creates two equal halves. So we can say GH is congruent to KH. And since we use the midpoint to decide that, that would be definition of midpoint. Okay, it's one of those things on the board that we've been using periodically. Alright, our triangles have three sides in common with each other, so we can prove the triangles are congruent. Triangle FGH is congruent to triangle JKH by side, side, side. Obviously these proofs are going to get bigger. Right now we're just getting used to the whole proof thing, so they're only going to be 3 or 4 steps. They're not going to be anything real major. Okay, you just got to know your properties and postulates and theorems. Alright, the next postulate in the series is side angle side. So you can kind of tell what the triangles are going to have in common with each other right now. It says if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the two triangles are congruent. So it has to go in order: a side, an angle, and a side. A side, an angle, and a side. The angle has to be between the two sides in order for us to use side angle, side. Otherwise, it spells something inappropriate, and so we don't want to do that. Okay? Side, angle, side, in that order. All right, so let's try this a little bit. We want to know, what additional information do you need to prove the triangle is congruent by side, 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 or side, angle, side? So let's start with side, side, side. How much more would you need for side, side, side? You only have one side right now, so we would need that side to be equal, and we would also need this side to be equal. That's a proof that's going to be pretty challenging because it doesn't have enough information. But for side angle side, you've got a side and an angle already. All we would need is this side right here. So this one is the better option there. And that's what you're going to have to do. You're going to have to look at a set of triangles and decide what we need to prove congruent in order to finish the proof. All right. How about this one? What would I use? Side, 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 or side, angle, side? Depends on what we're looking at. So for side, 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 you've got a side and a side, a side and a side. So we need the third side to be congruent. Okay. For side, angle, side, we've got a side and an angle. We would need that side as well. So for this proof, we could use either one, because they both need the same information to finish the proof. So then we would have to figure out some way to get that third side. And right now we don't have any information, so we don't have a clue what to do. But if they gave us something, then we could use that to our advantage to finish the proof. Alright, so last proof. We're going to try this out. You notice that it has a parallel in it? So we're going to use some of that stuff from the last chapter. Alright, so we're going to put this in here. RS congruent to KT, and then RS is parallel to KT. And that's given. And then we're going to go mark our picture. For RS is congruent to KT, we just put a line. If it's parallel, you put a little arrow on your line to show that they're parallel. Okay? So, we need to start looking. First thing I see automatically is you see this line going through the middle. That's a reflexive side because both triangles share that line. But this time it has to be named differently because it's twisted. If you look how the triangles are named in the proof statement, SK is congruent to KS just by the way they're written. Okay? I still call this the reflexive property because it's still equal to itself. We just have to write it differently so that it fits in the proof. Okay? And then we'll put little marks on it. So right now, our triangles have two sides in common. And that's a good thing. We can use that. So we've got this parallel statement where the top and the bottom are parallel. Think of the line through the middle as the transversal. So that would mean we'd have an angle here and an angle here that are congruent. So angle RSK is congruent to angle TKS. Those, if you remember from your last test, are alternate interiors. So we would use the alternate interior angles theorem that says if the lines are parallel and cut by a transversal, then the alternate interiors are congruent. Alright, so looking at this, my triangles now have a side, an angle, and a side. A side, an angle, and a side. So we can prove our triangles are congruent by side, angle, side. Okay, the only way to get better at proofs is to do proofs. So we're going to do a lot of proofs. You'll just have to get used to that. Okay, I'm not going to make them go away because we're not good at them. That means we're going to do more. Alright, so keep practicing.